Hello students, today we will discuss a very important network theorem that is called the superposition theorem. If you see, it is applicable to find the response in particular resistance in network having two or more than two energy sources. Clear? What are the energy sources? It may be the voltage source or it may be the current source. In this, we find the response taking one source at a time and the other sources are replaced with their internal resistance if any. Clear? मतलब हमें क्या निकालना है? We have to find the response. And what is the response? It may be the voltage, it may be the current, but not the power. Clear? It is valid for voltage and current only. Clear? तो यहाँ पर हम क्या करते हैं कि in this we find the response taking one source at a time. हम एक बार में एक सोर्स को कंसीडर करते हैं और उसके बाद जितने भी सोर्सेज होते हैं उसको हम उसके इंटरनल रेजिस्टेंस से रिप्लेस कर देते हैं. If the ideal sources are given, if there is the ideal voltage source, it is short circuited. If it is the ideal current source, it is open circuited. This will explain with the help of examples further. Now you will see this process is repeated for each source and the algebraic sum of responses. Algebraic sum of responses gives the required result. It is applicable to the linear network consisting of independent sources, linear passive element. It works for voltage and current but not the power. Clear? For example, if we say this circuit, this is the E1, this is the E2, this is the R1, this is the R2 and this is the R3. Clear? And we write R3 is equal to RL. Clear? आपको हमेशा ध्यान रखना है कि जो RL resistance है, it is the load resistance in which we have to find the response. Either it is the current or it is the voltage. Clear? You will see this is the I1, this is the I2, this is the IL. Clear? This I1, I2 and IL, it is the responses when we are considering the one source at a time. Clear? You will see suppose we are considering the E1. Clear? When we are considering the E1, this E2 is short circuited. Clear? Now the current flowing from E1, this is the I1 and it is divided into the two current I2 and I3 because these are the two parallel paths. Clear? यहाँ पर करंट क्या है बेटे? I1 और ये दो पार्ट में डिवाइड हो रही है, एक I2 और एक I3. As you know, in parallel circuit current divides. Clear? अगर हम यहाँ पर क्या लगा दें? एक लगा दें कि हमें I1 कैलकुलेट करना है. तो I1 कैसे कैलकुलेट करेंगे? R2 and R3 are in parallel. Then what is this? R2, R3. R2 is parallel with R3. Then resultant will be R2 into R3 upon R2 plus R3. Clear? This R2, R3 upon R2 plus R3, it is connected in series. That means the R equivalent, it is equal to the R1 plus R2, R3 upon R2 plus R3, and we will get the I1 that is equal to the I1 is equal to the E1 upon R equivalent. When you will calculate the I1, this I1 is divided into the two parts. That means हमने क्या करा? We apply the current division rule. Clear? और एक चीज देखिए, I2 that will be equal to the total current. What is the total current? I1 resistance of the other branch. Resistance of the other branch is R3. So I1 into R3 upon sum of these resistances, that is the R2 plus R3. Now you can calculate the value of I3. What will be the I3? Total current I1, resistance of the other branch R2 upon sum of the resistance, that is the R2 plus R3. Clear? Now this process is repeated for the E2. You see, when we are considering the E2, the E1 is short circuited because the E1 is the ideal voltage source. और आपको पता है कि आइडियल वोल्टेज सोर्स का जो इंटरनल रेजिस्टेंस है वो जीरो होता है, उसको हम क्या कर देते हैं, शॉर्ट कर दिया. और सिमिलरली वी विल कैलकुलेट द I3, I4 and I5. Clear? Now you will see I1. Clear? What will be the I1? Clear? देखिए R1 में जो करंट जा रहा है I1, जब हमने E1 को कंसीडर किया था और जब E2 को कंसीडर किया तो I4 है. यहां पर I3 I1 is going from A to B. Clear? और यहां पर क्या हो रहा है, ये B to A जा रहा है. That means what is the I1? That will be equal to the I1 minus I4. Clear? Similarly, what will be the value of the I2? Clear? The I2, it will be equal to the I2 here, ये opposite में है, that is equal to the I2 minus I3. And in R3 the direction of the current is same in both cases. That means the I3, it will be equal to the I3 plus I5. That means this is the algebraic sum. Clear? तो हम लोग क्या कर सकते हैं, हमें जैसे R3 बराबर RL था तो हमें क्या चाहिए था, केवल I3 की वैल्यू चाहिए थी, I3 प्लस I5. अगर ये RL होगा तो I1 कैलकुलेट करना था, तो I1 क्या होगा, I1 माइनस I4, I2 माइनस I3 in case of R2. Clear? Now you will see if I1 is greater than I4. Clear? अगर I1 जो है I4 से ग्रेटर होगा तो क्या होगा बच्चों, the direction of the current from A to B. Clear? If the I4 is greater than I1, the current direction will be B to A. Clear? It will be explained with the help of an example. With a start. Yes. Now we will see first problem of the superposition theorem. See the network. Here we are using the two voltage sources. As internal resistance is not given, that means it is the ideal voltage sources having the internal resistance. Clear? First of all, simply we will calculate the value of I1, I2 and IL. Clear? We are writing the RL because we have to find the current in 20 ohm resistance. Clear? यानी कि जिस resistance में हमें करंट निकालना होता है उसको हम क्या लेते हैं, we take the load resistance. Clear? Now you will see we will apply the node analysis to find the I1, I2 and IL. You will see this is the node and this is the node, and this node is taken as a reference node which is the zero potential node. Clear? यहाँ पर हमने वोल्टेज क्या लिया बच्चों, V1. Clear? Then what is the I1? That is the 120 minus V upon 10. What is the I2? I2 current is going from this to this side. That is the 65 minus V upon 60. And what is the IL? That is the V minus 0 upon 20. Clear? At this node we applying the KCL. Then incoming current is equal to the outgoing current. यानी कि इस नोड पर हमने क्या लगाया, KCL. That is the 120 minus V upon 10. ये किसकी वैल्यू थी, I1 की. 65 minus V upon 10 किसकी वैल्यू थी, I2 की. और IL की वैल्यू क्या थी बेटा, V upon 20. Clear? After solving this, we will get the value of the V, that is equal to the 785 upon 10, that is equal to the 78.5 V. Clear? When we will put the value of the V in this I1, you are getting the I1, that is the 4.15 ampere, I2, that is the 65 minus V upon 60, you are getting the minus 0.225 ampere, and the IL, that is equal to the 3.925. Clear? And now you will see what is the V, that is the 78.5, here the 65, and the current flows from the high potential to low potential. इसलिए करंट की यहाँ पर जो I2 की जो हमने डायरेक्शन ले रखी थी वो क्या हो गई है? It is reversed. Clear? That means it is the negative sign. Clear? So I2, that is equal to the minus 0.225 ampere. Clear? Now we will consider, we will apply the superposition theorem. First of all, we are considering the 120 volt. Clear? Now when we will consider the 120 volt, the other sources are replaced with their internal resistance. It is the ideal voltage source. Clear? That means it is short circuited. Clear? Now you will see, say this is the I1, this is the I2, and this is I3. Clear? Now first of all, you will calculate the I1. This 60 and 20 both are connected in parallel. Then what is the equivalent resistance? कितना होगा? अगर R1 और R2 पैरेलल में होते हैं तो इक्विवेलेंट रेजिस्टेंस होता है R1 R2 अपॉन R1 प्लस R2, यानी कि प्रोडक्ट ऑफ द रेजिस्टेंस अपॉन सम ऑफ द रेजिस्टेंस, दैट इज द 60 into 20 upon 60 plus 20. Clear? That is equal to the 60 into 20, 60 into 20 upon 80, 20 or 84, and that is the 15 ohm. 15 and 10, 15 and 10, these are in series. Clear? Then what will happen? 15 plus 10, that is equal to the 25. Clear? Then what is the I1? That is equal to the 15. Any doubt? Clear? So 15 plus 10, 25. This is the 120. That is the 120 upon 25. That is equal to the 5. 5s are 5, 2s are 4s are. That is the 24 by 5 ampere. Clear? Now we have to find the value of the I2 and I3. Clear? What is the value of the I2? आपने क्या करा? यहाँ पर करंट दो पार्ट में डिवाइड हो रही है, यानी कि यहाँ पर हम क्या अप्लाई करेंगे? We will apply the current division rule. Clear? Then what is the I2? Total current I1 into resistance of the other branch. Resistance of the other branch is 60 upon sum of the resistance 60 plus 20. Clear? That is the 24 upon 5 into 60 upon 80. Clear? 20, 3s are 4s are 4, 6. That is I2. It is equal to the 18 upon 5 ampere. I2, that is equal to the 18 upon 5 ampere. Clear? Now what is the value of the I3? I3 will be I1 minus I2. Clear? Or you can say 24 upon 5 minus 18 upon 5, that is equal to the 6 upon 5 ampere. Clear? Now you are getting the value I1. What is the value of the I1? Clear? I1, that is equal to the 24 by 5 ampere. 24 by 5 ampere. What is the value of the I2? I2 is 18 upon 5 ampere. What is the value of the I3? That is equal to the 6 by 5 ampere. Clear? Now we will consider this 65 volt source. Clear? Now you will see. यहाँ पर हमने वैल्यू रख ली है I1 24 by 5, I2 that is the 18 by 5. Clear? And the I3 it is equal to the 6 by 5. Clear? Now we will consider the 65 voltage source. Clear? When 65 voltage source is considered, this 120 volt is short circuited. It is short circuited. Clear? Now this is the resistance of the 10 ohm, Clear? This is the 20 ohm, 20 ohm. This is 60 ohm, 60 ohm, and here the source is 65 volt. Clear? Now see, say this is the I4. Clear? Now it is divided into the two part. देख लीजिए 65 से कितना करंट निकल रहा है I4, और ये दो पार्ट में डिवाइड हो गया. किसमें? एक तो हमने ले लिया I5 और ये ले लिया हमने I6. क्लियर? नाउ वी हैव टू फाइंड द I4. अब हमें I4 निकालने के लिए क्या करना पड़ेगा? अब देखिए 10 और 20 किसमें है? पैरेलल में. तो कितना रेजिस्टेंस हुआ? 10 into 20 upon 30. क्लियर? Product of the resistance 10 into 20, sum 10 plus 20, 30, 0, that is equal to the 20 by 3 plus 60. Clear? Plus 60, that is equal to the 200 upon 3. This is the R equivalent. R equivalent, that is the 200 upon 3. Clear? Now what is the value of the I4? That is equal to the 65 upon R equivalent. 65 को किससे डिवाइड करेंगे? R equivalent से डिवाइड करेंगे. That is the 65 upon 200 upon 3. That is equal to the 3 5s are 15. 195 upon 200. 5 3s are 15. 9s are and 39 upon 40 ampere. Clear? Then what is the value of the I4? I4, that is equal to the 39 upon 40 ampere. Now we have to find the I5 and I6. Clear? Now apply the current division rule. Clear? What is the I5? That is equal to the I4. Total current is I4. Total current कितना था? I4. That is the 39 upon 40 into resistance of the other branch. कितना है? 10. Clear? Upon I5. Resistance of the branch is 20. Upon sum of the resistance 10 plus 20. Clear? So 20, 39 upon 40 into 20 upon 30, 0, 0, that is equal to the 78 upon 120. Clear? So what is the I5? I5, that is equal to the 78 upon 120. Clear? Now we have to find the value of the I6. Clear? What is the value of the I6? That is equal to total current. Total current कितना था? I4, that is the 39 upon 40 into resistance of the other branch 10 ohm into 10 upon 30. Clear? That is equal to the 0, 0. Clear? That is equal to the 39 upon 120. Clear? तो हमें क्या क्या वैल्यू मिली? I4 की जो वैल्यू मिल रही है वो थी 39 upon 40. 39 upon 40. Clear? What is the value of the I5? I5 की जो वैल्यू निकाली थी हमने कितनी निकाली थी? That is the 78 upon 120 ampere. And what is the value of the I6? That is equal to the 39 upon 120 ampere. Clear? Now you will see, we have to find the current in RL. हमें किसमें करंट निकालनी है? RL में. Clear? तो what is the value of the IL? Clear? यहाँ पर देखिए करंट की डायरेक्शन कैसी है? A to B. यहाँ पर भी करंट की डायरेक्शन कितनी है? A to B. Clear? That means algebraic sum will be I2 plus I6. Clear? What is the value of the I2? That is the 18 upon 5. Clear? Plus what is the value of the I6? 39 upon 120. Clear? If you are taking the LCM, this is the 120, 5, 24. You will solve and you will get the value of the IL, that is equal to the 3.925 ampere. Clear? If it is the RL, clear? Then what will be the current? That will be the I1. This is the I5. Then this is the I1 minus I5. Similarly, you can find the resistance is 60 ohm. Clear? That means we can take any resistance as a load resistance. Clear? You will see. For example, this is the problem solved. Now we are taking some small changes. See.
Start.
Further we will see this network. We have to find the current in R3. Clear? We are writing the RL as it is the load resistance. Here we are taking two current sources. Clear? For example, if we are taking the I1. Clear? What is this? This is the R1. This is the R1 and this is R3, that is equal to the RL. This is the R2. अब हमें क्या करना है? We have to replace this energy source with its internal resistance. It is the ideal current source and the resistance of the ideal current source is infinite. That means it is open circuit. अब देखिए हमने इसको क्या कर दिया बच्चों? ओपन सर्किट कर दिया. क्लियर? अब देखो यहां पर जो करंट है, से दिस इज द IL1. क्लियर? यानी कि लोड रेजिस्टेंस में जो I1 के थ्रू करंट जा रही है वो कितनी है बेटे? IL1. अब देखिए ये साइड तो ओपन है, ये साइड ओपन है, तो जो भी करंट है वो इधर से पास हो जाएगी. क्लियर? दैट मींस व्हाट इज द वैल्यू ऑफ द IL1? That is equal to the I1. Clear? Similarly, you will see if we consider this I2, clear? Then what will happen? It is open circuited. It is open circuited, and the current is IL2. Clear? Now this I2 will be work as a IL2 because here is no current because it is open circuited. तो क्या होगा बच्चों? IL2 बराबर कितना है? I2. अब देखिए IL1 और IL2 इन दोनों की डायरेक्शन कैसी है? सेम. Then what will be the IL? IL will be equal to the IL1 plus IL2. Clear? अगर हमारे पास इस करंट की डायरेक्शन सपोज इस तरीके से होती, क्लियर, तो क्या होता? ये जो IL2 है, क्लियर, ये इस तरीके से जाता, क्लियर. अब यहां पर देखिए जो IL1 है वो A to B है, क्लियर, और IL2 क्या है बेटे? इट इज द B to A. क्लियर? नाउ द डायरेक्शन इज अपोजिट. क्लियर? देन व्हाट इज द IL? IL that is equal to the IL1 difference IL2. क्लियर? या IL1 माइनस IL2 लिख दीजिए. क्लियर? अगर पॉजिटिव आता है तो करंट कहां से फ्लो कर रही है? A to B. और अगर निगेटिव आता है तो क्या करेगा? इट इज फ्लोइंग फ्रॉम B to A. क्लियर? You will see another example. If we are taking the one voltage source and one current source, one voltage source and one current source, you will see, say this is the E1, this is the E1, this is the R1, this is the R1, this is R3, and this is RL, R2, and this is the current source. Say this is the I. Clear? And we have to find the current in R3. तो हमने इसको क्या कह दिया? That is the RL. Clear? When we consider this E1, clear? When we are considering the E1, clear? This is the R1. This is the R1, and what is this? This is the R3. ये कितना होगा बेटे? R3. ये कितना है भाई? ये हमारे पास R2, और इसको हम क्या कर देंगे? ओपन सर्किट. क्लियर? जब हमने इसको ओपन सर्किट कर दिया तो जो करंट है, से दिस करंट इज I1. क्लियर? और यहां पर जो करंट है, से दिस इज द IL1. क्लियर? Then what will observe in you? That is the I1. It is equal to the IL1, that is equal to the I1. तो आपने क्या करा कि पहले हमने वोल्टेज सोर्स को कंसीडर किया और इसको क्या कर दिया? ओपन सर्किट किया, and we are getting the value of the IL1. Clear? Now we will consider the current source. तो क्या करेंगे? वोल्टेज सोर्स को शॉर्ट कर देंगे. Clear? This is the R1. Clear? This is the R3. R3. Clear? That is the R2. And this is the I. This is the I. Clear? Now we have to find this IL2. You will see this current I is divided into the two part and we have to find the value of IL2. हमें किसकी वैल्यू निकालनी है? IL2 की. अब देखिए जब IL2 की वैल्यू निकालनी है तो क्या करेंगे? करंट डिवीजन रूल लगाएंगे. तो टोटल करंट कितना है? I. टोटल करंट इज I. Clear? Total current is I and IL2 that is equal to the total current into resistance of the other branch, that is the R1 upon R1 plus R3. Clear? Now the algebraic sum of IL1 and IL2, it will give the required current in the load resistance. Here the direction is same. That means what is the IL? That is equal to the IL1. IL that is equal to the IL1 plus IL2. Clear? तो आपने देखा कि हमने जो कोर्स किया, आज जो हमने पढ़ा, जो एग्जाम्पल ली, उसमें हमने एक एग्जाम्पल ली पहले कि जब हमने दो वोल्टेज सोर्स को कंसीडर किया था, फिर एक एग्जाम्पल ली जिसमें हमने दो करंट सोर्स को कंसीडर किया था. उसके बाद हमने जो कंसीडर किया वो एक वोल्टेज सोर्स और एक करंट सोर्स को लिया था. क्लियर? इन नेक्स्ट लेक्चर वी विल सॉल्व सम इंपॉर्टेंट प्रॉब्लम्स बेस्ड ऑन सुपरपोजिशन थ्योरम. क्लियर? इफ यू हैव एनी प्रॉब्लम you can write me on email and further we will discuss your problem. Clear? Thank you.